Well, welcome everyone to a Pleasant Future Vision Passive House Source Zero Energy Home Tour. We're excited that you can join us here for this virtual tour from a home in Birmingham, Michigan. Now, it's important to keep in mind, no matter what type of project you might be building or constructing, whether it's big or right-sized, rural, suburban, or urban, the sustainability aspects of this project are replicatable in many ways at all levels, and you can definitely learn something. So keep that in mind as we go through this tour and understand, even to some extent, you can apply these ideas and concepts to existing home renovation and gut rehab strategies. Now, before we get started, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, over 300 members who support our work, and a huge thanks to our sponsors, especially our platinum sponsors, Rheem and Mitsubishi, who are making products to help decarbonize and meet many of these goals we're going to be talking about here today. This session is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your session moderator. I am the education manager here at the GreenHome Institute, Brett Little. And as always, this course is approved for multiple continuing education units, including all 5 pillars of green in our certified GreenHome professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. And you can grab the Passive House Certified Passive House Consultant code at the end or in an email once you've attended the entire session. So a Pleasant Future Vision project came from not just 1, but 4 different GreenHome Institute members and their teams to really make it happen. So first we'll hear from our longtime member and supporter, Michael Clement, who will take you back into the past behind the drywall of the project and show you some of the design and construction. Then we'll hear from our member, Jake Lepan of Fireside Home Construction on his process on the build side. And for the majority of the session, we'll hear from our members, Harvey Bell, about living in the home and getting some of the operational data a year later. And finally, a shout out to our member, Chris McTaggart of Dream DET for providing the HERS and Passive House Rating certification for this project. Now, before we hand it over, we want to say a huge congratulations to this team too for recently winning the Michigan Energy Efficiency Contractors Association Project of the Year Award 2024. So with that, Michael, please take us back into the pre-drywall construction process, and then we will continue to go from there.
Hello, my name is Michael Clement. I'm the principal of Architectural Resource. We are a custom residential sustainable design firm based in Ann Arbor, Michigan, but doing projects across the country. And we're here today to talk about what is behind me, the Pleasant Future Vision. This home has been pre-certified as the world's first 2021 Zero pre-certified home. As an overview, this home is 3,900 square feet above grade finish, 2,200 on the first floor, 1,700 on the second. It also has 1,200 square feet of finished space in the basement, bringing the total to 5,100 square feet. What we're going to have an opportunity to do today, which is unique, is really take a look at what's under the hood. See what are the component parts that are going to constitute this high performance home. So without further ado, let's go on in and have a look. This home has been designed to be the first CEUS Plus 21 Zero certified home in America. And in fact, in the world. What does that mean exactly? A CEUS Plus 21 Zero certified passive house is a home that uses, by design, orientation, and construction, 80 to 90% less energy than a conventional home. But this home goes one step further in seeking the Zero certification. By that we mean that over the course of a year, this home will generate as much power as it needs to operate. They've taken it one step further. They're also adding additional generation capacity to take care of charging vehicles and pool heating. So this is a really extremely exciting project. First in Birmingham, first in America, first in the world. So we have an opportunity here with this mock-up to explain to you this high-performing double stud wall assembly. This is perhaps one of the most resilient, robust, passive house enclosure envelopes we've ever designed. This mock-up is showing you what's on the inside of the exterior wall. So this is the floor framing, and we're showing the floor deck. Then we have a sill plate, a window opening, header, the double top plate, the second floor assembly, all the way up to the top plate, and then this is showing what's going to be up at the ceiling. So this is a compressed version of the actual wall. On the inside of this house, it's built pretty much like a conventional home. We've got 2x4 framing, we've got 3.5-inch wall insulation, we've got wood eye joist. Everything is pretty much the same. This wall, the interior wall, becomes our load-bearing and structural wall. What's really exciting about this is what goes on the other side of this assembly, where we're going to talk about the double stud assembly to the exterior. We're on the exterior surface of the wall that we had shown you previously, which is basically built as a conventional wall. 2x4 framing behind this green sheet. This green sheet is something called zip sheathing. In conventional construction, this would be considered the outermost layer of the wall. In this wall, this is actually the inner layer of the wall. It's in the center of the wall with a 2x4 frame wall beyond it and a secondary 2x4 framed wall in front of it. This is why this is referred to as a double stud wall. We have the structural sheathing, the structural framing. Everything behind this is conventional. And then to the outside of that, we're building a secondary stud framed wall, which is going to allow an 8-inch cavity to be filled with insulation. There's going to be a 4.5-inch space here and a 3.5-inch space here. And by setting the framing off of the exterior sheathing, we get the thermal bridge break that's going to help us reduce our energy transfer through the building. One of the things you're noticing here is the tape. Because this green area is our air control layer, all gaps and seams need to be taped. This is a small version of what would be a much larger window opening. What we've done is created a rough buck. This is a 3/4-inch plywood enclosure that's attached back to the structural wall. It reaches forward, and as you can see, the tape is brought forward and wrapped back in where it will engage with the window, making a continuity of the air control layer. This then will have an additional layer on the outside of something called Den's element, which we'll talk about when we take you to the outside. And then mounted to the top of that is going to be a drainage matrix called Home Slicker that's going to provide a 1/4-inch gap. So when we put our siding on the top of this, any water that gets behind the siding is able to drain down, out, and away. This is perhaps one of the most resilient, durable, high-performing walls we've ever designed. And it's really exciting to share this with you. When we design a high-performance building enclosure, we go about everything we can do to make sure we're managing the water and keeping it out of the walls, which is great until we go ahead and put holes in the walls and call them doors and windows and ask them to carry forward that same level of rigor. One of the things you'll note here is at the top of this window, there is something we call drip flashing. This is a piece of that flashing that's already been installed. That will take any water that lands on top of the window and direct it down, out, and away. And you see how that's been incorporated into the weather-resistant barrier with the liquid flashing. This weather-resistant barrier is called Den's element. Den's element is a really special material in that it combines the functions of the WRB with the functions of the air barrier in one product, one installation. This eliminates the need for a separate application and saving multiple trips around the house. The really exciting thing is that for this high performance, high R value wall, we have to pay particular close attention to moisture management because we've radically reduced the energy flux across the wall and thus reduced the drying potential. Den's element has an insanely high perm rating of 30 as compared to a typical OSB sheathing with a perm rating of around 2. Perm rating is a measure of the ability of a material to pass vapor moisture. The higher the perm rating, the greater the ability to pass moisture. This is a super high R value, high performing wall that can dry inward through the drywall, but also dry outward through the Den's element, leading to a super durable wall. But wait, there's more. We also have concerns for water that might get into the window assembly and need to find its way out. If you look underneath this sill, you'll see that there's more metal flashing doing the same exact thing that's happening at the head. This metal flashing goes back under the window to create what's called a sill pan. So this way we have our first line of defense at the head, and then if any water happens to get into the window opening, it has a chance to come out. This allows us to take an extreme level of moisture management to this building, making it highly durable and highly sustainable. We're up at the second floor of the Pleasant Future Vision Passive House, and we can share with you how we're managing the lid. The lid is the top of a building, which is very important in terms of convective energy management. Warm air rises, and as diligent as we need to be with penetrations in the air management layer in the walls, we need to be doubly diligent up here at the ceiling and the lid. If you look above me, what you'll notice is there's that same zip sheathing that we had used for our air management layer in the walls. In this case, it's turned flat. It's attached to the underside of our truss framing system, and all of the seams are taped, all the penetrations are sealed, and the idea is to create a super rigorous air management layer, in particular at the lid. Above that, we have cellulose insulation, which is giving us an R110 compared to code minimum, which is 38. So as you can see, there's quite a bit of difference in terms of performance from a standard code minimum to a passive house high performance. So once we have the zip air and vapor control layer underneath the trusses, then we install the interior partitions. This is a little bit out of sequence because what typically happens is the trusses are in place, the interior partitions go up, and then comes the drywall. In this case, we are closing off the air and vapor control with the zip sheathing and then putting the service cavity underneath that, allowing drywall to go to the top of the partition, as you can see here. So we have a really robust building envelope all the way through from bottom to top. As the saying goes, a high-performance house needs a good pair of boots and a good hat. Here we're on the exterior surface of the Pleasant Future Vision Passive House. This is something that's called Home Slicker. What this does is allow us to attach our siding and provide a three-dimensional drainage and air ventilation matrix behind it. This then brings it down to flashing, which again, much as what we had done at the window at the sill and at the window at the head, that idea of controlling the water past this exterior surface out to the exterior of the surfacing on the foundation. Down, out, and away is a strategy that we carry all the way down to the grade. We're now down in the basement of the Pleasant Future Vision Passive House, and I'm going to share with you how we've designed the wall assembly, the foundation wall. Many people think about roof and above grade walls, but the below grade walls are actually an important component of a high performance building as well. In this case, we're using something called ICF, or insulated concrete form. What it is a 10-inch concrete core with 2.5 inches of expanded polystyrene insulation on the exterior of that. We are also, in this case, putting a 2-inch layer of board insulation to the exterior of that, that's serving both a R value enhancing purpose as well as acting as a drainage mat to allow water that comes to the foundation to run down the foundation face, exterior of the waterproofing, which is mounted to the outside of the ICF. And then inboard of that, we have a stud frame wall cavity that's held off of the ICF that's also going to be insulated. All told, the R value of this foundation wall assembly is going to be R48. Code is R10. So again, as you can see, there's a significant difference in terms of maintaining the energy in a home, both above grade at the roof and down below grade as well. We're in the basement of the Pleasant Future Vision Passive House, and we want to talk about the slab. We know how important the roof is, the lid. We know how important the exterior walls are above grade. We've talked about the below grade walls. Here's an opportunity to talk about the slab, that part that meets the soil. In this case, we have a 4-inch concrete slab that has a polyethylene vapor control and air control layer underneath it that's continuous. Beneath that, we have 2 layers of insulation, a 2-inch rigid insulation layer and an 1.5-inch layer. Those 2 layers with offset and staggered seams create a thermal break that gives us an R value of 17.5. Code only asks for R10. So we're dialing up the energy performance in the underslab condition. This house has 2 other layers which are key to the performance, and that is a 12-inch layer of pea stone and a 12-inch layer of 6A rock. Those 2 layers are helping us defeat any type of groundwater that may be coming up from below, because we have water that comes from the heavens in terms of rain, we have wind-driven rain, but we also have soil water that would come up. You've probably heard the old mantra, a house needs to breathe. Well, actually a house doesn't need to breathe. People need to breathe. And in most cases, our houses are not only breathing, they're hyperventilating. The DOE would say that most of our homes built conventionally have the equivalent of a 24-inch by 24-inch hole that's allowing inside air that you paid to heat, filter, condition, leave, and then unconditioned air from the outside come in. Behind me, you'll notice these gray corrugated pipes. These are part of our high-performance ventilation system, because in a passive house, we take a mantra which is build it tight and ventilate right. What we do is we use an ERV, an energy recovery ventilator, that extracts humid, stale air out of spaces such as bathrooms, laundry areas, kitchens, and we exit that to the outside of the building. We bring in fresh air, and we're able through the energy recovery ventilator to recover the heat and humidity from the outgoing air. So let's say it's the winter time and we have 0-degree temperature, 10% relative humidity air outside, and we have 70-degree and 30% RH air inside. We're able to recover some of that humidity and heat on the incoming air, upwards of 89 to 92%. That air comes into the house and is then delivered to the living spaces, bedrooms, gathering areas. In this way, we keep constant ventilation moving through the house, but we're not leaking energy. This is how we approach ventilation strategies in a high-performance passive house.
All right. Well, thank you, Michael, for taking us through that. We've got Jake here, the builder from Fireside Home Construction with us. Jake, just wanted to hear from you quickly on, if I understand correctly, this is perhaps your first passive house certified home that your team was involved in, and correct me if I'm wrong there, but just, from the construction standpoint and what your team was going through, what were some of the challenges, opportunities, lessons you were learning along the way on a project like this?
Yes. Yeah. So this was our first official certified passive house that we've done. We've done other certified projects, both with Michael and some other, high performing projects in general. But the biggest challenge on this project was the air tightness. Like the whole, as you can see from those wonderful videos that Michael put together, this house is like an onion. There is three houses worth of building envelopes in this type of home. So maintaining like the air tightness and understanding the construction sequencing and making sure that everything is being wrapped and taped from the inside out, because it is absolutely critical to have the house be, we're trying to build as airtight of a house as possible. And we achieved some very great air tightness standards on this home. For a passive house, they used to do it as a 0.6 ACH 50, which is like a volume test. They've since recently have changed it to an exterior wall square footage style of test. So, but back in the ACH 50, it was required a 0.6, which is a very, very, very airtight house in general from a building standpoint. Michigan code is 4. So we're talking magnitudes air tighter. Well, on our passive house, we were able to achieve a 0.3, which is, to our understanding today, we haven't seen any other examples yet, but we believe right now this passive house is the tightest house in Michigan. We had some unofficial blower door tests get as low as 0.1, but when we did the actual final certification at the end, the final test came in at 0.3, which we are absolutely thrilled with. But achieving that level of air tightness requires a lot of understanding on how all the layers go together. There was a lot of communications back and forth with myself and Michael's team over there. And then the other issue that we ran into on this project is we were running into material availability issues multiple times through the project. And it's not like a typical project where you can just say, oh, I'm going to order a bunch of foam from the lumber yard when it's called out for something else, because a passive house has 4 different control layers. And if you change a material, it can impact how the air, how the moisture through diffusion impacts that wall system. So in order to achieve the goals and everything that was from a pre-certified standpoint, we had to rigorously go through the drawings and everything and make sure we had a very clear understanding of that air control layer around all sides of the box of the house, and then also executing it. We had to have direct oversight every day on the project, because these types of projects, a lot of trades have no idea about it yet. So there's a lot of oversight and quality control that you have to do to be able to build a super insulated house that's airtight as possible, thermal bridge free, to maintain those principles. And then to do that and then achieve it, you just have to have a high level of oversight and quality control on that. So those are kind of the biggest challenges if you've never done it before, and with this being our first certified passive house, we really had to dial in on those details and make sure we did not miss anything. Because when you're looking at that wall, that little mock-up we made, you can see the inside stud wall, the outside stud wall. We have to have flashings and tapes and everything that get into that inside wall from the outside. And if you miss one or if something gets missed, now you're talking about disassembling a wall system, because, the goal is to achieve the certification, so, there's just a lot of detail and construction oversight that has to happen every day.
Great. Well, Jake, I appreciate you joining us and sharing that with us, and congrats on hitting those super low air leakage tightness targets. So, and Jake and Michael, they're going to be sticking around for the official Q&A that we'll jump into. Now we're going to transition. We transition from, mid-construction to talking about the construction process to operations and actually living in a home like this. And our longtime member and supporter, Harvey, who commissioned this project, is here with us to talk about his experience, living in this home and sharing the information with you and why this is even important to him. So, Harvey, are you there with us? And go ahead and welcome and take it away.
Okay, well, I'm fighting with my camera at the moment, but hopefully you don't need to look at me while the camera figures out what's going on. So,
yeah, that's fine. Yeah, go ahead and share your screen. We'll figure it out.
Okay, thanks very much. So, it's really a pleasure to be able to do this and work with Michael Clement, Susan Hall, and Brett. And the same thing with Jake and his team. What he said was absolutely critical about having a team that could really work this project well. So we'll go ahead and share my screen here. Somebody else is sharing, cannot share screen while the other participant is sharing.
You should be able to now, Harvey. Go ahead. Sorry.
Okay. So on me, I worked for GM for 39 years before I flunked retirement and was recruited to be a professor of engineering practice at the University of Michigan. So 1 year later, what have we learned living in a pleasant future vision? And what's unique is actually 1 year ago today, we moved in to the house. So the house we tore down was built in 1947. And this house right here on the left, you see, and we lived in that house since 1989. Actually, that's the second house we lived on Pleasant. We moved in as a year short of our first anniversary in 1975. And so now we have a house that we moved into on May 8th, 2023. So our vision is we wanted a home to age in place and thrive as we aged. Same time, we wanted this home to be sustainable, so we enabled future generations to thrive. And broadly speaking here, the home is fully electric. We've got about 21 kilowatts of solar power and 45 kilowatt hours of batteries in the basement. We've also hired landscape architects to retain all the rainwater on the property. We've got 6 rain gardens and then 3 1,500-gallon cisterns. Here I'm going to flip through a couple of the certifications that we've got in terms of certificates. You will know, Jake mentioned we had a number of tests, and Chris McTaggart, the certified grader, the one of all the ones he pulled off, he actually pulled off 0.31 air exchanges per hour. But you can see here, it's a -20 HERS score. The DOE 0 home readiness, certified for indoor air plus by the EPA. We have an Energy Star certification, again from the EPA. And then the Ecotrope people had a carbon index at a HERS rating as well. So if you look at the systems, and part of this is, it's one thing to build a really, really energy efficient house, but there's a whole nother level of energy efficient operation that can be achieved. And to do that, you need to have data. Sort of one of my mantras is, God, we trust all others, bring data. We actually have 6 air quality measurements, 3 of them that are more complete in AirThings View Plus, and then 3 AirThings Mini. The solar converter, the 15K that is married to the simplified batteries, we'll show you a picture here. And then 2 main Mitsubishi mini splits. Well, we have 3 mini splits. There are 2 of them that are connected and we can Wi-Fi monitor. The Rheem heat pump, hot water heater is connected to the Wi-Fi system. The Zender ERV is connected to the Wi-Fi system. We also have some Hobel temperature and humidity monitors buried inside the wall to monitor the temperature and humidity. So here's some shots. You can see the solar panels, the 47 solar panels. You know, the bulk of them are on a pretty steep pitch, I think 14, 12. And then in the basement, you can take a look at the Solarc inverter, and married to the Simplify batteries. There are 12 3.8 kilowatt hour batteries there. Might mention that Simplify in the last year has been bought by Briggs and Stratton, and they appear to me, looking at the material I get fed, as building a very tight relationship. Briggs and Stratton Energy and Solarc, the manufacturer of the inverter. I'm going to talk a little bit more about the inverter in a second. Here you've got a screenshot of what really looks, what the air monitors can look like. You can, you know, from radon, particulate matter, carbon dioxide, humidity, temperature, and volatile organic compounds. If you look here, for instance, in my office, it was warm the other day, and these other monitors don't look at particulate matters, only humidity, VOC, and temperatures. We got 3 of the simpler ones in the bathroom, the kitchen, and in my office. And the more complex ones in the bedroom, second floor in my wife Kay's office, and in the basement. So what did we learn? One of the most significant issues we learned about is radon. So in spite of the sophisticated, spelled wrong, radon mitigation systems, the radon got very high in the basement during a very cold weather snap in January. So this was driving me crazy with all this, and after some playing around and talking to some Zender people and doing some research, the cause was the frozen ground. It was -5 here, and when the ground freezes, the radon can't escape out through the surface, and it was building up a concentration in the 3 window wells in the basement. So the solution was that we had to get into the advanced controls on the Zender ERV, and we very slightly take the house to a positive pressure. I am convinced that houses of this type, that have been built this tight, should not be perfectly balanced. They should be at a very slight positive pressure so that the seals on all the windows and doors are fully loaded. And really, really critical. I'll show you some data here to what happened to the radon concentrations after we did that. So here you can look at the trace, and this top trace, and I don't know if you can see it, is radon starting in January when I bought this sensor, or not, in about October when I bought this sensor. And you'll notice this peak right here in January, and I've got another chart with a little more detail, but it dropped very quickly, and you can see that happened rather sharply in terms of in a time frame there. So the next slide, a little more detailed, blown up in terms of between January 21st here on a Sunday, got really high by Tuesday, and actually into the area that is labeled red. And then where we pressurized it, the house dropped back down into the green area based on radon levels. So that was one big learning about radon, and really the need to take a very, very high tight house, very, very slightly positive, particularly if you're going to put it in cold weather climates where the ground can get really, really cold. Now, one of the other things that it was interesting is when we first moved in, all the landscaping wasn't done. And the ERV inlet's 24 inches off the ground. And when they moved dirt around, radon went up and and I didn't have a way to actually work the solution, but I would advocate ERV inlets need to be more than 24 inches above grade. So now, Canadian forest fires. You know, we had a really bad summer last year. Here is a picture of the intake filter from the ERV. The Zender ERVs have MERV 13 filters on the intake side. Now, what's really significant, and also I should point out that our mini splits, our larger mini split air handlers in the basement were modified to put in MERV 13 filters so that the air that's going through the house is also filtered. And I think that was critical as well. On the intake side of the ERV, we are right now on our 18th filter. So we were changing the filters during the summer and the peak of the Canadian forest fires less than, once a month. And yeah, more than once a month. And you could watch the air monitors and the particulate matter would start to go up when the filter got breaking through. And if you talk to Zender, they would tell you that these filters should last for a year. But when you have a terrible ambient air quality, like we did during those Canadian forest fires, these filters and the ERV system make it very, very resilient to the ambient air quality variation. So really, in terms of occupant health and comfort, I would tell you from our perspective right now, a totally balanced ventilation system does not guarantee comfort. So the walls that Michael and Jake explained to you, they have a very, very high thermal inertia. This house does not change temperature very fast. And because of that, you need to sort of do an internal balance almost in terms of the ambient weather, the sun load. And I look at temperature, trying to get an optimal sleeping temperature for the bedroom. And for somebody that has sleep apnea, I try to keep the bedroom between 70 and 68 degrees. You'll recognize from a FIA standpoint, a lot of other people that they suggest during the summer, they want to do their calculations at 74 degrees. That just does not work. And you can still maintain a net positive house by paying attention to that. In the winter months, because of the ERV, the house became unacceptably dry. And so we actually have added a humidifier to the original plans in an effort to try to hold the house around 45%. And in our monitors that we have in the walls, we've always maintained a 20-degree differential between the dew point and the temperature in the wall. I should also mention that the ERV gives us a tremendous benefit with the kitchen range hood. And the community, as they're going through the design, was worried about makeup air for the kitchen range hood. And we were able to determine that the ERV could go positive. And quite frankly, there's a guy, Brett Singer out of the Berkeley National Laboratories, that would tell you that the air that needs to come from outside the kitchen, inside the kitchen, to really get all the volatile organic compounds. Even though we don't have a gas stove, we have a induction cooktop, you can still get harmful volatile organic compounds out of the cooking process. And so we can take and actually set the ERV to run in a supply only mode while we are running it. Someday I think I'm going to write some software such that that happens automatically, but that's a project down the line. So domestic hot water. So certainly the hot water heater and the fact that it's tied to the internet, you can set on 4 times a day, you can change the temperature, and that's coupled with a very precise recirculating system that my wife Kay found. And well, a lot of the recirculation systems are actuated by buttons or timers. This one has a combination of a timer, and then it uses the hot water valve as an actuator. So when a flow sensor in the system senses that there's flow, it'll start the pump, and we end up with pretty much instant hot water. But you can really minimize your hot water usage or energy into heating your hot water. I would also mention that you need to reset all your shower valves that are set up so you don't scald yourself. They assume, 140-degree hot water temperature tank. And in our case, I oscillate between, depending on the time of day, between 127 and 129 overall. So, we've got an electrical system that we wanted. Our objective was to minimize fossil fuel use and maximize generation of renewable energy during the grid peak needs so that we can maximize the societal benefit. We have a pricing schedule with DTE known as dynamic peak pricing. The very lowest times to buy electricity is between 11 p.m. and 7 a.m. And then the highest times to buy it, or the best time to sell it back to the grid, is between 3 p.m. and 7 p.m. So the Solar 15K inverter has a tremendous amount of capability that enables the user to optimize time of day pricing schedules for maximum capability, and gives you the capability to monitor the system. So pretty slick in that case. So I'm going to stop this sharing and share something else here with you. This share is going to give you a view real time of what's going on. And what's interesting here is from the time that I started this here, so you can see over on the left, we actually have 2 sets of, the bulk of the solar panels are coming through this area over here where we get 12.5, 12.6 kilowatts. Up here, there's another 3.6 kilowatts that is coming through a terminal on the Solark that's set up for either an additional inverter or a generator. So if you had let's say a natural gas generator, you could come into the terminal there. Solark has some flexibility, but in that we had more than the nominal 15K of solar capacity, we needed to tap into that extra terminal. Right now, we're pumping out about 14 kilowatts to the grid. The batteries are fully charged. I've got a screenshot a little bit later that'll show you just exactly what it looked like earlier. But it's a nice, bright, sunny day here in southeastern Michigan, and we're pumping out a lot. And it's not quite, the sun will peak at 3:35 here, so it's not quite there yet. So I'll go back to my other presentation at this point, and we'll
Screen share.
yeah, I know that. I got to get back up. So okay, hopefully we got right back into the right. Hopefully you can all see that. You made that transition well. So this will give you a shot at internally into the Solar 15K, but you can see I can choose based on the day of the week, whether I want to charge the battery, whether I want to sell to the grid, and then there are time cuts. And this is just the very first one that starts at midnight that said, I don't want to bring any more in than 4,000 watts. So that'll just give you some sense of the programmability of this inverter. So in the time of day, we've had to really modify our behaviors in that we do the laundry on sunny days. You know, I like to run the dishwasher, it's sort of my job. So I choose the optimal times to run the dishwasher based on the solar energy, where the battery is. We're going to charge the car during optimal times. Probably after I get done with this presentation here, I'll go out and charge it. Here is a screenshot of what the Solarc was, you know, what happened between midnight and 8 a.m. this morning. During the night, I'm running the house on the battery. These spikes are the mini split on the first floor turning on to cool the bedroom. And you can see you're looking at both the grid and the load. As the sun started coming up, just a little bit after 6 o'clock, the green line and the yellow line are the solar panels coming up. You can see the amount of power that we're pulling from the battery decreases, and the red area here on the end is what the load at the house was. So the solar cells are beginning to pick the load up from the battery. Now, in terms of net zero, this will show you for the whole, since we've been in the house, the red bar for 2023 is how much we've imported. The green bar was for 2023, how much we exported. And then over here on the right is 2024. Again, the same setup, export or import versus export. And these numbers up here on the right are for the total time or the total, you know, year. We've exported a little over 9 megawatts, and we've imported 1.8 megawatts. So we're positive. We have a net positive account with DTE, not of 1.8, because in January, we exhausted our positive account, and we're rebalancing it now. Here's what happened during the year. As I just mentioned, in January, it was cloudy and cold, and we had to import a lot. And I might add, I imported the power during the middle of the night. And then we were actually positive very slightly in February. And it's still where I did import it. I imported it during the middle of the night. And then we did the same thing. We just got in this electric bill from DTE, and that was $25. So how do we do after 1 year? We've got an 84% reduction in our utility bill because we don't have any natural gas. We're the tightest house in Michigan at 0.231 air exchanges. We've essentially eliminated the stormwater runoff charge from our municipal water bill for about a 38% reduction in our water bill. And as Brett mentioned, we were just awarded the Michigan Energy Efficiency Construction Association Project of the Year. So I'll stop sharing and we can do questions. Yeah.
Thank you so much, Harvey and Jake and Michael. Let's we've definitely got some time for questions. We're going to be going through a lot that are coming in. And as those questions are coming in, just a real quick reminder that yes, this session is being recorded, and you can catch it on our YouTube channel in the next couple of days. You can go there and take a look, or you can go there right now, hit subscribe. You'll get an instant update when it is available, and you can watch it. For those of you watching this session in the future, but not right now on demand, go ahead and head over and take your quiz with an 80% passing rate, and you will receive your continuing education units. For those of you here today, go ahead and check your spam in the next couple of days for certs at gutenbergcerts.com. Take the survey that pops up as well. and you'll get your continuing ed certificate from there. And just a real quick before we get into those questions, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, over 300 members supporting our work, allowing us to do this, and our top tier sponsors and all of our sponsors, especially Rheem and Mitsubishi, who are making all electric products that help decarbonize and meet many of the sustainability goals that we talked about here today. So I want to organize some of the questions the way they're coming in, kind of going back to the beginning and talking about the place you start, right, with that thermal envelope, with that shell. Very important to get that right. So let's get into those questions and then maybe move into some of the mechanical questions and then some of the operational questions and go from there, if that's all right. So the first one that came in right out of the top, literally, was asking about the R110. I've never heard those words before. So it's a new world we're living in. So what was the modeling decision in terms of the cheapest place to put that insulation? And so I think it's a broader question, because if I understand Passive House and the energy ratings, you kind of get to choose to some extent, right? Especially Passive House, they do require certain thresholds, but after that point, you kind of get to choose where to put it, and the model kind of tells you. So maybe Michael, just to kind of go to you, how was that decision made?
That's a really great question. And 110 got our attention too. It's 100. That's the highest R value we've ever specified for any home. Brett, it's exactly as you're saying. In the Passive House modeling software, we get to choose, which is what's so beautiful about it. It's a dynamic software. So we can choose where to put the effort to reduce that energy exchange between the inside and the outside. And what we typically find is the cheapest place to do it is in the attic. Mm-hmm. We typically like to use cellulose insulation, which is one of the lower cost insulations, and it's a higher benefit to the planet in terms of its carbon impact. And an extra 5 inches of cellulose in the attic is cheap insurance to high performance homes. It does impact the energy hill. We do have to raise that up. So it does have design and aesthetic decisions we have to take into account. But what we typically find is our kind of get out of jail card is the attic and the insulation we're going to do in the attic.
Mm-hmm, mm-hmm. Jake, any, just from your perspective, from the construction standpoint, was there anything that stood out doing that level of insulation in the attic? Is that something you've done before?
We typically would put in like an R60 or an R80, to go from a 50 to a 60 is a really low cost, like less, like you're talking hundreds of dollars. To go from like a 60 to an 80 for a whole entire house, you're less than a couple $1,000s and having that big impact. But like Michael referenced, was you have to, when you have 30 inches or 32 inches of blown in cellulose in your attic, yes, you want to have a much higher heel height on your truss over top of the wall, so it's not tapering down and being reduced as it comes into over top of the wall. Also, even if this wasn't a passive house where we had that air control layer on the bottom of the trusses, where we saw that green zip sheathing on the bottom, basically creating a lid of your ceiling, we would have had to do that anyways, just to help hold up the weight of the cellulose. Like 5/8 drywall does not have enough backbone to hold up that much cellulose without sagging or any uncoupling issues over time. So, so there's just a couple of details in regards to that for that level of thickness of insulation. But, we usually typically achieve R60 and R80 on our high performance projects. So it wasn't too much out of the realm to go that next level.
Mm-hmm. And one thing I want to add too, Brett, while we're on the subject, and Jake's kind of pointing to it, it's highly unusual to put exterior sheathing on the undersurface of a truss. And we do that for two reasons, as Jake was pointing out. One is it does provide a perfect air control layer with a zip system with proprietary tapes. The other is it provides that strength to support that level of insulation. So to my designer colleagues out there, make sure you review your truss shop submittals very carefully for dead load on bottom core.
Yeah. Now, kind of going down a little bit to the walls here, the question was, if any of you, either one of you, can recall the R value of the double wall. I think if in the handout you all can access the energy rating, so I do believe it gives you some information there. But if that number jumped out to you real quick, and then the other question is, what was the insulation installed in the double wall?
You know, it'll take me a second. I will find the R value for the wall.
Okay.
Something in the 60 kind of rings in my mind, but I will find that.
Yeah.
So I do want to address a really great question is this exterior material, this DENS element. So we're doing a lot of explorations at Architectural Resource on cost-effective ways to try to generate high-performance homes. And the double stud wall, as you're seeing in this project, is picking up prominence in the industry. So a lot of people are looking at this. We did some advanced energy modeling and WUFI hygrothermal analysis working with the folks at the Passive House Institute of the United States. And as you may know, they're very conservative, and that's great because we know that Harvey and Kay are going to have a well-performing home. But whereas many people are using just standard OSB sheathing on the outside of double stud walls, the performance criteria that we were looking at with the Passive House Institute did require a much more vapor permeable exterior wall to prevent any possible issues with condensation in the wall. So this DENS element, I think I mentioned in the video, is a perm rating of 30. I mean, 30. Like, what is that, like newspaper? I mean, it's so vapor open, it's crazy. And we encouraged Harvey and Kay to consider putting monitors in their assemblies, and they took us up on that suggestion. And this wall is performing beautifully, even with Harvey running the humidity up to 45% in the winter. So it is a system, as all of you probably understand in this call. A high performance home is a system. It's a component parts that work together as a system, and it has to be thought through as a complete system. So that exterior sheathing is very important. And I'm going to go looking for the RVAC.
And Jake, any other, I guess, because you mentioned the challenges on the air tightness, and that's a component of the wall, of course, but just, you know, constructing double stud walls, you know, what is there more of an effort to do that versus traditional wall assemblies?
It's, well, with the way this wall assembly was done, is with the interior wall being load bearing, we could construct that load bearing wall and then keep moving forward with the process and go up. And then what we did was the outside non-bearing wall that was built kind of after the actual structure was all roughed in. So that way we could properly tape, seal everything on that green layer before we have another wall in the way, even if it's just open studs in the way on that. So that way we could then put in portions of the DENS glass. So it could be a backer for the blown in cellulose. Because the outside or the blown in on this project, we use blown in fiber, dense pack blown in fiberglass. And that, you know, gave us a backer to be able to actually have something to dense pack against. So, because there's some, you know, you have to take that in consideration on how are you going to get 8 inches of cellulose in a big wide cavity that's, you know, 10 feet tall by 40 feet long or longer. You know, so we were able to take advantage of the fire blocking that we had to put into that exterior wall system to have something to dense pack against, along with installing the DENS glass and pretty much leaving like a 1 foot wide rip out of there. So we could dense pack everything vertically from above down up to that area, then net off that 1 foot strip, and then just have to dense pack that 1 foot strip and then put the DENS glass over top of it. So we were doing all this process while building. So that's kind of where it was kind of going into like that whole talking about understanding the sequencing of how you need to do everything and working with building officials because they're not used to seeing anything like this. This is so far above code minimum. We had multiple, especially on the insulation, we had multiple partial insulation inspections, and then we thoroughly explained everything that we were doing on that first partial insulation inspection with the building inspector. They said, okay, we're going to have the interior insulation inspection. We're going to have an exterior. You're going to be looking at the foam under the slab, you know, and having all these things because you just, you know, we take a multitude of pictures, but nothing beats seeing it in person. So there's just a lot of sequencing that you had to be aware of on that standpoint and get everybody on board, and go from there. But to answer the insulation question, we used the dense pack fiberglass, which had the same R value rating as the dense packed blown in cellulose. And the primary reason why we switched to that on the interior program is we get a better finish when it comes to the drywall with the dense pack fiberglass, because it like stays compressed and it doesn't want to pillow out at the bottom of the wall. So the drywallers aren't trying to push all that cellulose in at the bottom, because the netting tends to want to stretch at the bottom of the wall. So that, you know, gave us a little bit better quality control for the future trades coming in that were non, you know, infrastructure related. So that helped us provide a better product for Harvey and Kay.
Okay. Now another question that came in was about the floor assembly relationship to the top of the foundation. And I think this kind of came in during, you know, one of the end of the videos. And the individual was just saying, at least from their perspective, it seemed like there was some kind of thermal bridge inherent in the detailing. I don't know if you can speak to that a little bit, especially.
Yeah. So there was that we were, it's a great question, because we were very mindful of how we're going to manage that interface. And as everyone knows, well, as most know, where the walls and the floors come together is where the issues occur. So how we address the thermal bridging, we had the foundation inboard 2 inches from the outside plane of the exterior wall. And the exterior wall, remember, is not load bearing. And we ran continuous rigid board insulation up to meet that wall. And then in the bond area, we use high density spray foam to create an airtight barrier there and link those two together. So we were, a great question, because there's always areas where we're trying to find how are we going to possibly do that, and it just takes a little bit of thinking.
Another question that came in was about the insulated concrete forms, the ICFs in the basement. And was there a decision to instead just continue that all the way up, right? So a lot of homes just get built full ICF. I know we've got a couple members committed to that. Was there any consideration or conversation there on that end?
It's certainly a possibility to continue the ICF all the way up. What we typically find is it's a cost delta that doesn't necessarily play out in our client's favor, but that's not taking anything away from that. That's definitely a possibility to build for sure.
Yeah. Is that something you all see, Jake, or do you build with all ICFs once in a while on projects? Or?
Yeah, we have a lot of experience with ICFs. You know, my business partner, who is retired now, but when he started fireside home construction back in the mid 90s, he was building high performance homes using ICFs, structural insulating panels or SIPs, and all those types of building components. And, you know, since I've taken over here in 2017, we've done several as well. It definitely comes down to an overall cost standpoint. ICFs work great if you're looking for it to be kind of like you're trying to do like a high performance system that's not going to potentially be like a certified project, because when you have to hit those certification values, you're adding a bunch of layers already on top of that ICF wall system. And, you know, there's a lot of fluctuations also in regards to the ICF that's more than just the ICF material itself. You know, you have like the concrete costs, which are always in flux. And, you know, and then when you're also dealing with like a passive house, yeah, the ICF can definitely help you with your air and vapor control layers. But then also, like we saw, I think we were in the between an R40 and R50 on the exterior wall insulation. Now you're talking about adding a bunch of layers already to an ICF wall system, and where are you going to do that? You know, it's kind of like when we did the ICF basement, we still had the ICF system for the basement. We had to put exterior insulation on the outside of that, and we had to put interior insulation on the inside of that. So you're adding all those layers to an already what some would consider a premium building product. You know, the costs can just kind of get out of control, and you know, now we're trying to figure out how do we reduce costs to make the project viable.
Yeah. Another question that came in was, is there an advantage to recessing those windows rather than mounting them flush with the outside wall surface?
Aha, the any outie question. So thermodynamically, it's optimal to put the window at the midpoint between the thermal climb of the wall.
Mm-hmm.
If we push it to the outside, which is what some folks like to do, we run the risk of actually, in a passive house, creating little convective loops inside the window that can lead to slightly different temperature situations and potential for condensation. It's easier to build. It's easier to weather manage. Just ask Jake. He's just gone through it. And then the other option is to put it to the inboard. So we always, when possible, we like to opt for center of wall, and we use mounting clips to mount the windows. That really lets you fine tune that assembly. But it is not an easy construction. Hats off to you, Jake. Hats off to you.
One of the other wall questions that came in here before we jump into systems and operations here real quick. I lost it here. Yeah, so regarding the exterior wall construction, how is the outer frame wall anchored to the inner structural frame wall? And so they're just asking, is that achieved with a 3-4 inch plywood horizontal components shown in the wall section?
Yes, we basically build fins using plywood to link those together. And the reason we use that was, again, to try to reduce the thermal bridging.
Yep.
And again, hats off to Jake. That took some carpentry skills. Because once you build those, that's your plane of your wall. You're not shimming.
So kind of getting into, Harvey, you pointed out the radon and you shared with us what was going on in the winter, and hopefully not a surprise to a lot of people. Radon tends to get worse in the winter, better in the summertime due to pressures and other various things, at least in Michigan anyway. I've noticed it too. So the question is, did you actually have an active radon system installed? I guess that wasn't quite clear in the conversation.
The radon system, there's no blower or anything. It's, Michael and Jake there's no blower. So it's a passive system, but I'm convinced it was coming through the window wells based on everything else and the response and how quickly it responded once we took the house. Very, very slightly positive. And quite frankly, Larry Pisano out of Zender had talked, even before we had the house complete, he talked about that, and he and I had a lot of discussions. So it was something I sort of gravitated to pretty quickly.
Is the system, I know a lot of times they'll put in the passive systems and they'll be pre-wired to turn active if there's an issue. Is that something that occurred on this one, or is it just a total passive system then?
Total passive system.
Yeah. Okay.
And I think, quite frankly, that's probably the right decision. Subsequently, I've sort of worried about some of these active systems, and they can break and everything like that. And but I think there are a lot of other slight advantages to having a house positive. Every window is not going to be dimensionally perfect, and so you got all these windows, and the seals need to be very slightly loaded. And taking the house positive a tiny bit is, I think, a really good thing. And clearly, the house is tight as we are. Having a house very tightly positive, you're not losing energy, which is, why people want balance houses, right?
Right. And
the other thing too about slightly positive, those who are on the call who are familiar with building science, is usually recommending slightly negative in a cooling climate. However, the wall assembly that Harvey and Kay have, that Jake so beautifully built, was literally gleaned from Building Science Corporation's guides for double stud walls. So it is, anyone who's looking at this thing, they have an interior sheathing in the center of the wall on a double stud wall. Yes. And by doing this wall assembly, we can let Harvey take his house positive and not worry about having any moisture issues in the wall. And we have hobo monitors to confirm that. So we're feeling really, really good about this assembly.
The house actually performed at a better ACH 50 when they did the positive pressure test versus the negative test for the blower door. So it's even tighter. Like Harvey's mentioning, it's even tighter.
Yeah. Now, a specific question came in about the passive radon system constructed. Was it with a form drain or just a pipe in the capillary layer?
So we have underneath. So basically, what we have in this house is a super drainage system. There is a layer of 6A stone, which water can move through that, and it will maintain its compactancy. Then there is a layer of 12 inches of pea stone underneath the basement slab. And then around the entire perimeter, we did what we call the burrito, which is just picture like a high draining fabric, like a geo grid style fabric, that we literally make like a 3-foot diameter burrito that has a drain pipe in it that also connects into the exterior drain, and it's completely wrapped in fabric. So if any water that gets in from the outside, it has like 3 feet of pea stone on the outside and multiple layers of stone on the inside. So there is nowhere for like water or any gases or anything to not try to navigate out. And part of the problem why Harvey was having the radon in the window wells is because those window wells were pretty much sitting on top of that burrito, that pea stone burrito. So that's the only spot where gas could get out, where we didn't have frozen ground above it. So those were the only collection points. And there's window well covers on the actual escape window wells. So that kind of created this little pocket for a weak point for any of that gas to want to get out. Because correct me if I'm wrong, Harvey, when you're using your sensors, the only spots you were actually picking up radon is when you would put the sensor on the actual window sill. Everywhere else in the basement, it wasn't picking it up. Is that correct?
No, well, I moved it around, but I mean, I first started finding out about it because, I had it sitting over on that sink in the basement in that room for the grandkids. But then I started moving around. That's part of what led me to the diagnostic that was in the window wells. And I hadn't thought about your burrito, but you're absolutely right. And at that time, there was snow on top of those panels for the escape out the top of the window wells. So I think that burrito you're right on about that one, Jake. And that just makes all the more sense in the diagnostics that I stumbled through, gives me some even more confidence. And it wasn't until we got that real cold snap in January, everything else, the radon in the basement had been, dead nuts, very, very low.
So continuing with some of the systems questions, was just a elaboration again. You don't actually have a true range hood, right? You have the hood there that's going through the ERV. It's not vented out. Is that correct? No.
We have a range hood.
Oh,
That is, and you needed to do that to comply with the EPA indoor air quality, their new standard. So yeah, we have a range hood, and as we were going through this process, Kay and I watched a lot of YouTube videos and ended up with this guy out at the Berkeley lab, Brett Singer, who had done a lot of work on range hoods, and it was sized over the cooktop optimally, positioned optimally. And then, but he did one study that showed clearly makeup air that's going to go out through the range hood needs to come from outside the kitchen in. And that's when all of a sudden, dawned on me, we got this ERV, and
I see.
it has a capability that you can go actually set it all supply, no exhaust. So we were forcing it through. So, the ERV, the range hood is nominally 400 CFM. We set it up for 300 CFM. So I think that answered another question
Yeah, yeah,
potentially.
that's right. And that's why you said the ERV goes into supply only mode, not vent only. I had to think about that. Now I understand it. So you're just helping replace that air.
Yeah, and sooner or later, I think the ERV and the range hood can be connected to the Wi-Fi systems.
Yeah.
And I think there's software, somebody's gonna figure out how to, even though they're different manufacturers, and there are probably gonna be a lot of different manufacturers, somebody's gonna write some code pretty easy.
Yeah.
Say, oh, when the range hood is on, put the ERVs in supply only mode for that short period of time. Meantime, we've got a monitor for volatile organic compounds sitting right on the kitchen island. And it's pretty, the biggest thing that sets that thing off is fresh peaches from a farmer's market.
Yeah. The other question that came in is you had mentioned you had added that, I believe it was a whole home dehumidifier. Just to clarify, it's a whole home dehumidifier in your system and not just a separate source or a room dehumidifier.
No, it was specified as part of the whole CEUS piece. It's a dehumidifier. It's running down in the basement.
Yeah.
As a matter of fact, it's not right. There's some sort of malfunction with it at the moment, but fortunately, we're in a shoulder season here, so I get that fixed. And then I saw a question also relative to MERV 13 filters in the mini splits.
Yeah, that was very surprising.
Well, the mini splits don't come with filters of that capability in. The HVAC installer took it upon themselves to put in as they built the inlet for the air handler in the basement, a standard furnace, 5 by 5 by 24, whatever it is, 25, system 20 by 24, 5, I think, standard filter out of, and we've been using those pretty effectively. They don't get dirty near as fast as the ERV intake filters, but they get dirty because those MERV 13 filters only taking out 90% of the particulate matter.
So just to clarify, is the MERV 13 filter built into the ERV, or there's actually those tiny little filters that go into the mini split? Somebody made a custom 13 one.
No. So you need to think of a standard furnace filter.
Yeah.
From that's 20 by 24 by 5.
Right.
And so you buy MERV 13s at Menards.
Yeah.
And before where that typical mini split filter would be, just in the ducting, they put in a box big enough to put in those on the intake side for the air handler.
Okay, so this is a ducted system.
This is a ducted system.
Yes.
That's the
that's where I think we were getting caught off. You have a ducted air source heat pump system.
Yes.
Yeah.
We
And
have
you just built in.
Yeah, we have 3 of them.
And you just they built in the additional add-on because we were just to look because I was trying to envision a MERV 13 going into a mini split. And I'm like, that's hard.
No.
Yeah.
Ducted, and so there are only 2 of them that have that.
Gotcha. Well, then on that note, on that conversation, was a mini split approach considered for this project versus the trade-off of a full ducted system? Was there any conversation there, or was it just like, nope, this is the way we got to go?
So I'm gonna let Michael answer.
I'm sorry, Brett, once more.
So was there a and maybe let's bring in another piece of the question. When you were considering the design, passive house costs, we always have the choice between a ducted system versus a ductless versus ground source heat pump. Let's just throw that in the mix. Did those conversations come into play? Which way we go? Is it ducted versus ductless, ground source heat pump, and how that might impact the project?
Good question. So we are, in general, we are leaning towards ducted air source heat pump systems. There's a couple of reasons. Their efficiency is really solid. It takes the cabinet off the wall. It can be, we can run multiple heads off of different, our single outside units. In this case, we have multiple outside units. So we're really, there's a multitude of reasons. Aesthetic is not one of the smaller ones in terms of doing that. But the other thing is that some of the mini splits, we're running into some, we got some reports from the field that they're running into some mold issues, mold and humidity issues inside the actual cabinets.
Mm-hmm.
So for all these reasons, we don't want to mess with that.
Right.
Certainly not for Harvey and Kay. So we went right away to ducting.
And was ground source conversation here, or?
Ground source, yeah, great question. So air source heat pump, which is what Harvey and Kay have, or ground source, which we know as geothermal.
Yeah.
So what we consider for what Harvey and Kay did, rather than spending the extra money in the geo system and the wells and everything else, they put that money into the envelope.
Right.
So they upfront paid for conservation. So they're going to be reaping benefits from that from now until forever. So when you increase the performance of the building, you can go to air source heat pumps with the SEER ratings that we have these days, and you can be perfectly fine.
Sure.
If you have a conventional home and you want to upgrade it, geosystems can make sense because they've got a little bit more punch, and it doesn't hurt to have the 30% federal tax credit right now.
Right. Yeah.
So the other thing I would add to that is the people immediately to the south did a similar thing toward their house down and rebuilt it. They put in geothermal. And when I was over through that house during construction, it reminded me of being in the Navy and the engine room on the ship. Very, very complex. And it seems like every 6 months, they've got some sort of issue in terms of making that system work as complex as it is. So far, these things have been very, very reliable, and we've been pleased with them.
Well, what you just said is interesting based on one of the questions that came in the perspective of somebody who was listening this whole time. They were feeling the same way about what you were saying. Of course, they were saying, hey, what if I want a home like this, but I don't want to have to kind of monitor all this stuff and deal with all this stuff and have this information? What can all of you kind of speak to that? Like, can we have these homes like this and make sure they're operating without having someone to have to look at, energy data coming in, air quality data? I know I enjoy doing that. And clearly I can tell you do, Harvey. So I'm biased, like I want to, but I know the vast majority of people don't want to, they don't have time. They need to make sure they can get this performance without dealing with it. Can you, I guess, just how do you speak to that a little
Well,
bit?
so one of the things you have to know that my family teases me about spreadsheets and data. So
I was going to go there, Harvey. We're talking to Harvey Bell and Kay Bell.
Yeah.
You really don't know. In fact, Harvey, when we first met and we were interviewing to help him and Kay out with their project, he said, I'm going to ask a lot of questions. I'm going to really push you. I had no idea. I was kidding. Harvey is the most pleasantly data-driven person I've ever met in my life. And so to those who are listening, Harvey's all about optimization, right? He has an engineer mindset. He looks at any situation in life and he thinks, how can I improve this? How can I reduce the impact on the environment? How can I reduce the cost of operation? So what you're looking at is Harvey. He's in his element. I mean, he's fine-tuning pressure positive during when the fan's out. He's having a blast. But that is not what you have to do to enjoy a passive house.
I would
not
agree.
at all. In fact, the joke used to be back in the old days, a passive house requires an active homeowner. That is no longer the situation. These houses are plug and play, set and forget.
Yeah.
And in fact, one of the issues we run into is if you like temperature deviation, colder bedroom at night, whatever, it's like Harvey said, these things have thermal memory. So it's a little hard to make that adjustment. So you set your house to 72 degrees and you can walk away. And it also has what we call drift potential, right? So passive survivability is a kind of the technical term, But the idea of if Harvey and Kay were to lose power for a month, it's highly unlikely that their house would ever drop below 45 degrees just with their internal temperature, their body heat, their BTUs, and their cats.
Right.
Well, and we were talking about that before we came on, Harvey, and you were talking to me just sort of how you're, even in the wintertime, right, with the battery system you have and with the solar, there's still some opportunity to generate power during a cold snap outage, right?
Yeah, there was a question Rakhov had relative to how we did the sizing. Actually, when I started through this, the discussion was, what are we going to do for backup? Because in the old house, we had a backup generator. And so, you know, Kay and I talked, and she said, we should have 3 days of reserve. So I calculated the electrical loads that would be minimum loads. And then I calculated how much battery we'd need. And so that's how I arrived at the 45 kilowatt hours of batteries. Now, I will tell you right now, there's a new product out on the market that, you know, here it's a year later, but this whole area is moving so fast. And relative to being what I'll call plug and play and walk away, you know, even the solar people are quickly adapting the control systems and so that you'd get in and program it once. And I think, quite frankly, a knowledgeable solar installer, and we had one of the best, but he get it in, programmed everything. He could put you, you know, 85% of where you need to be that you could walk away. Now, Michael's right, and my family teases me and everything. I'm not going to walk away. I will be playing with this for a long time.
Yeah.
Harvey, I'm going to challenge you to turn the furnaces off in the winter and during one of those polar vortices, and let's just see. Let's push this. Let's redline this baby and see how she performs.
Yeah. Or maybe we run that test while I go skiing.
Yeah. Yeah. You can monitor it from your phone, from your air things.
You're right.
Yeah. Just turn it off and report back to us on what the temperature is. And yeah, I'd love to know it. So talking about solar, it looks like you are, and congratulations, you're 1 year in. You mentioned your 2,000 or almost 2,000 kilowatt hours, what we call net positive energy. So congratulations, you're a true net zero homeowner. But my question is, you have an electric car, that's clear. Do you have a sense of, because when we talk about a net zero home or a net positive home, we try to actually segregate out the car. Now the future is to include the car, but for now, just to be fair, we want to segregate it out. What sense do you have of that usage is the car versus just the home in general? So
total free expression here. I've had the car 1 week.
Oh, okay.
It's taken them quite a while. I got a pretty, you know, interesting car, but also the interesting paint color. It was the last color they chose to let the factory paint. In any case, that's going to be very, very interesting. I'm probably going to charge it, you know, try to shoot for noon, and when I get off this, we'll go out and charge it. But we'll keep track of what my gasoline usage was, and I go back and forth to Ann Arbor. That's an 80-mile round trip. Nominally, you know, that's 4 trips before a complete, just charging the battery did, you know, a little bit. I hopefully can get 4 trips, but regardless, anytime the batteries are fully charged and I've got a sunny day, I'm going to plug it in and take it to an 80% state of charge.
Okay,
so I don't know. Really... Call me back in 6 months, and I'll have more data to share with you, Brett.
Yeah. So really, it sounds like you've got a nice snapshot of your home independent of the charging, and now you can kind of get that electric car usage. Okay, well that's fantastic. So and based on what I see on my car, I think you'll be, if it's the same, yours is more efficient, clearly. You'll be netting out just fine with what you have. So I don't know if you're all willing to discuss or share this, but some questions that came in about cost. So maybe I'll just ask it this way. You talk a lot about the home being above code, right? In many aspects, energy savings and some of the specific parts around the wall. Clearly the HVAC is above code. So then what does that translate to construction cost, in percentage or square foot above code? And is there any willingness to share that or discuss that?
I'll let Michael and Jake answer that,
Yeah.
but I will also tell you, we did this in the middle of COVID.
Right.
And the amount of shortages and where I think things, if you were to do, this, the windows came from Poland. The American manufacturers are not going to let this market drift away from them. And I think there's a lot of areas. The other thing I would tell people is we operate this house, and I get into a lot of discussions relative to people. Well, solar pay for itself, and then you're asking the wrong question. I think, quite frankly, from any number of points of view. But the key is what happens to your total utility bill, natural gas, electricity, and what would be your fuel going into your vehicles, and what's going to happen into the future when your vehicles have got a bi-directional capability. So now I'm going to go from 45 kilowatt hours of batteries probably to 250 kilowatt of batteries in storage, and the flexibility to really minimize an operating cost almost down to zero. So things are going to evolve. And my perception is, as Jake and all the builders work for building not only a passive house, I think there's a whole sales pitch on a healthy house. Because even, we've bought some screens to try to open the windows, but if the air quality outside's terrible, you can't open windows.
Yeah, and that was another question that came in too, is if you use natural ventilation, and obviously you have air quality monitors, so you wouldn't be using your windows if you're detecting poor air quality. Is kind of the way I was looking at it, and the way I personally do it too. So, but Michael, Jake, I don't know if you wanted to add any more on just what you see with, the above code construction versus a home like this, and any context to that anymore?
Yeah, I mean, I could tell you from a cost standpoint, what we're seeing for like high performance, and then this type of level of house, which is like the next step up. So for a all-in retail cost, which is like everything for the infrastructure, everything for the site, grading, everything that's included. And we're looking at it from a square footage standpoint. It also includes like the attached 2-car garage, your porches, everything that's around the house, up into landscape and hardscape. It might not. Generally, it wouldn't include like rain gardens and things like that, or a bunch of hardscaping. So up to that point, you're realistically looking at around $500 a square foot at a starting point for a passive house. And then when you add if you add rain gardens as that part of the feature, they were using that to get away from their high water and sewage bills, which it worked. And also, hardscaping and things like that, depending on how much you can do, very little, or you can have an extensive landscape hardscape plan, which isn't required to build the house. That's just a personal preference. So, but to like this style of home, you're looking at a starting entry point for everything, for all the infrastructure and all the finishes on the inside, very nicely appointed. If you're building a house like this, you're not usually putting in Home Depot countertops and, ordering your light fixtures from Menards and stuff. Like, you have quality fixtures, quality finishes. Typically the inside of the house is going to match the type of quality you're putting into the infrastructure of the home as well. So, so from this standpoint, you'd be looking at, like I said, $500 a square foot starting point. If you're doing a high performance, not at this level, then you're kind of in that $400 to $500 a square foot starting range. And like I said, that's all inclusive for everything up to ready for the landscaper to come in and put down topsoil and grass seed or sod or plantings and all that stuff.
Yeah.
And I want to just add a little bit too, and what Jake is saying is exactly what we're seeing in the market. Those ranges seem very, very familiar. But Jake and I and Harvey and Brett want everyone who's listening to understand that this is the pinnacle project that we have ever done in our entire professional career. These systems we did for Harvey and Kay were the top drawer. And that's what Harvey and Kay wanted to invest in. Do you have to go that high? Absolutely not. There are ranges of performance that can be achieved. What is the same is the physics, the building science, the attention to detail, the quality that someone like Jake and Fireside is going to bring to the construction process. Mm-hmm. And then you decide where you run out of oxygen in terms of what you want to invest in your project. So we don't want, I mean, you're looking at this, I mean, you're looking at literally, this is the state-of-the-art project that we at Architectural Resource have ever designed. And we've done everything from there down to code minimum, which, by the way, anything less is illegal. So when someone proudly boasts that they build code minimum, well, of course they do, or they'd be out of business.
Well, you know, one of the other things, the city of Ann Arbor has an ordinance where they've got, as you sell your house, you've got to have a HERS rating on it. And I think the city of Ann Arbor is trying to set it up so that there's recognized value in you know, Jake and Michael's future in the work they're doing. I don't know, Michael, if you had any hand in that ordinance in Ann Arbor or not.
We try to stay clear of government as much as we can.
No, but you're right, Harvey. That is another value point, is eventually these energy ratings will be popping up during home sales. People will be asking those questions and saying, you know, not only what are your bills, but what is this rated for? And that's going to have, you know, increase the value, yeah, you know, of homes like this, and I think increase the construction and renovation, yeah, of that approach as well. So,
said one other real quick thing I noticed in the question chat thing, there are pipes that pick up the radon in the under the slab. Uh-huh. I don't know if Jake left the impression somebody walked away with the impression there's no pipes under there.
Oh yeah, there's a grid of pipes throughout underneath the basement slab in all that pea stone.
Mm-hmm. Another quick question that came up too was on the passive solar approach, and the question is just, I don't know if Michael, if you have a quick off the top of your head, you know, the square footage of south facing glass as a percentage of the total floor area.
You know, that's a great question, and one of the things that we endeavored to do with this house is have this house be beautiful from the street, which faces due east, and have it also access the backyard, which faces due west. And so we have large areas of which you can't see from Harvey's picture, but you kind of got a glimpse when we did the flyer on the aerial video. That was taken into account. So too was the specifications of the glazing that we use in those different orientations. Very important. And the energy model takes that into account. So that's all part of the calculation for energy performance.
Right. Well, we're a little bit over our time here, and we've gotten through a lot of questions. I'll definitely send out any of the other remaining ones that came up. Before we wrap up, maybe I'll turn to you first, Michael. Where can people go to contact you and learn more about your work? So,
absolutely. So my name is Michael Clement. I'm the principal of Architectural Resource, and we are a small residential design firm based in Ann Arbor doing projects across the country. We are a team. So I'm here speaking on behalf of our team, but I want to acknowledge specifically Susan Hall, who was our project designer on this, who did a absolutely phenomenal job. There's no one to match Harvey's intensity than Susan. Susan and Harvey were like two planets orbiting, and it was just an incredible process. So you can go to architecturalresource.com.
All right. And Jake, where can people go to contact you and learn more about your fireside home construction?
Yeah, it's our website, firesidehomeconstruction.com. It's pretty easy. So that's we have all kinds of project information on there, contact forms, anything like that. So feel free to reach out to us if you have any questions or anything like that. We'd be happy to see how we can best assist you with any type of new construction, or we also consider ourselves remodeling and addition experts, and can kind of help value engineer those types of projects in regard, and also do certified projects. So feel free to reach out to us. We have a contact page on our website, and that comes right directly to everybody here, and we get a quick response back to you.
And you're building like Southeast Michigan?
Yeah,
primarily? Yeah.
So our office is a little northeast of Dexter. We are near North Territorial and US 23, which is just a little north of Ann Arbor. So we like to stay within an hour radius from that kind of intersection there. So we go west to Chelsea and Grass Lake and towards Jackson, and east out towards Birmingham, Royal Oak area. As long as it's kind of within that 1 hour radius, we're happy to serve you.
Okay. And Harvey, are you going to be putting up, I know some homeowners like to put up a blog and share their story, share their results. Are you doing anything like that?
Not yet. No, I have conceived of that, and potentially, but the semester just ended, and I've got to get my head above water. I might set up a YouTube channel to talk about operating principles and things like that.
All right.
But I've got a lot of student engineering teams that need some guidance at the moment.
Sure.
I got to make sure my eyes are not bigger than my capability.
Well, if we see anything and you share it with us, we'll share it out with everyone else so we can keep learning.
Or I'd be happy to take questions through. If you get a whole series of questions and somehow want to do a chat with a group of people, we'd be happy to do that along the way.
Yeah, maybe we'll have you back out again for a further update.
Well, yeah, see if people give you a bunch of questions or something like that, want to know about how it's going, we could put something together.
Yeah.
I mean, we could do a live broadcast when you have the house in drift mode. Yeah. After 10 days, we could. What do you think, Brett?
I love the idea. So yeah, we'll wait for that next cold snap. Yeah. All right. Well, Michael, Jake, and especially Harvey for making this commitment and doing this work and putting in the effort so we can all learn and keep doing it. Thank you so much for your time and joining us and going through all of this. I really appreciate it, and I learned a lot. And thank you all for joining us. And as always, we'll catch you next Wednesday. So take care and be well, everyone. Bye.
Thank you, everyone.
Thank you. Goodbye.
Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.